Alright guys, so I know that this isn't even in Minecraft, but I'm teaching you about Minecraft stuff, so you don't get to judge. Alright, so today we're going to be looking at the two number systems of Minecraft. Binary and hex, usually abbreviated like this. Hex is just hex, it's short for hexadecimal, and the BI is short for binary. I'm using an online whiteboard, so ignore it. And so binary is just base 2. Hex is base 16. Now, I don't like the thickness of this. There we go. Here we go. That's a good thickness. Let's see. So I had to explain this to you in any sort of way. If I had to explain this to you in any sort of way, it would be that base 10 is the thing we normally use. It has 10 symbols or digits, or 10 different numbers. So you can tell that this is not scripted. So because it has 10 different numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then it's considered base 10, because 10 numbers. Binary is base 2, so it has 2 numbers, 0 and 1. So that's what you see in like game codes, because sometimes you can like find code and stuff and you're like, what even is this? You've probably heard of binary before, or just seen it. You had to have seen it in some place. And so that's basically what binary is. Now, hex is a different story. Hexadecimal is base 16, which means that there aren't enough symbols. We have 0 through 9, but then we have to cut into our letters a bit. A, which is 10, B, which is 11, C, which is 12, make some lines between these, D, which is 13, E, which is 14, and finally F, which is 15. Now you can see that I have not proportionalized this at all, but also that we now have this, and this is what Redstone uses. I'm just gonna, instead of erasing it, just move to a different part. See, so Redstone can be 0, and then 1 through 15. 15 is what most things make, like redstone torches gives 15. Levers gives 15. And stuff like redstone blocks gives 15. Now, obviously, this is normal. Now, if things are unpowered, it goes 0. And every time that something travels, so 15, 14, 13. So these are all x. Then this is x minus 1, x minus 2, and x is just the starting thing. And then you just go dot, 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 because there's more. And so for each one, x equals x minus 1, and for everything that generates power, x equals 15. However, in such things like comparators, as we learned last episode, things take in and then put out the same thing. So then this could be x minus 1, and this would still be x. This would be x, because x now equals x minus 1. I forgot the minus sign there. So this is the new x. But it doesn't really matter. X, this is also x, this is also x, and then after each line, x equals x minus 1. So you just decrement it by 1. Now, while that is used, it is not very common that you will see me using it because I do not like hex. I just prefer... Oh yeah, also another thing about hex, before I get back to binary, is that you can use barrels. This is how you make ROM most of the time. This is how you make hexadecimal ROM. You use barrels, then you use a comparator. Look at my amazing drawings. And then the comparator outputs something. It outputs an X for whatever is inside the barrel. So a full barrel would output 15, and an empty barrel would output 0. So that's all that's about hex. Now let's talk about binary again. How exactly do I read binary? Let's say you have 1, 0, 1, 0. See, so each of these is 2 to the power of their place value minus 1. So this is the 1, then this is the second one over, third one over, fourth one over. So this would be 2 to the power of 0, 2 to the power of 1, which is, so 1, 2, and then this would be 2 to the power of 2, so 4, 2 to the power of 3, so then that would be 8. So then this one would be 0, then this would be, can't forget the addition signs, just going to put those in there as a small addition there, then 4 times 0, okay, wait, first 2 times 0 is 2, 4 times 0 is 0, and then 8 times 1 is 8. So this one is 10. If I wanted 20, I don't exactly just double it. Well, I do double it, but doubling is complicated, because when I double something now, instead of just being 1, 0, 1, 0 to 2, 0, 2, 0, I have to reevaluate my life choices. See, so 1, so a 2 is 1, 0. So this would be 0, okay, this would be 1, 0, and then this would also be 1, 0. You just doubled the number. This is 20. You can tell because 1, 2, 4, 8, 16. 16 plus 4 is 20. This one's equal to 10, as we already know. So there you go. That is how you read binary. Reading binary fast is almost impossible, so I'm not even going to get into it. Next, back, wow, this just hates me. Next, back on to hex. Back on the topic of hexadecimal. So how do I read hex? Let's say you have F. Well, it's basically the same thing as before, but instead of 2, we have 16. So I'm going to actually space this out a little bit more. See, so this is 16 to the power of 0, and then this is 16 to the power of 1. So 16, and remember, F is 16. So this is 16 times 16. So this would be 16, and then 16 times 16, hold on, let me think. I got it. I think I got it. Hold on. Wait, no, sorry. 15. So, in reality, this is actually 15. And so then this would be... Dang it, I messed up my calculation because I didn't... 240, because it's 15 times 16. So then 240 plus this, so this would be 255. That's also the secret behind